For the Takakura paper, the data is contained within a graph and not actually tabulated. What you need to do is extract the mean values and also find the interquartile ranges so that you can calculate what the standard deviations are going to be. You could do this just by measuring on the PDF or on the paper using a ruler or a caliper if you want to be more accurate, or you can do it in a digital way using a program such as Plotdigitizer. I have the actual licensed version of Plotdigitizer, but if you don't have the licensed version, you can use the free online version. So if I launch the app, I've created an image file from the PDF. So I just did a screen grab of that part of the PDF that contains the graph. And if I drop it into the application, you can see it here. Now, when you're in the application, you've got things here which are Y1, X1, Y2, X2. You need to use these to scale the graph, to create the reference points. So X1 is at 0. Y1 corresponds to X1 and is also 0. That's the origin of your graph. Y2 is the maximum of the y-axis, so it goes to the top, and that's 100. And X2 is arbitrary in this case, but I need to try and get it as horizontally aligned as I can to X1. So I'll put it there and I'll give it an arbitrary 100. It doesn't really matter. So this has calibrated the image that you've got on the screen. And now you can pick data points and it will tell you what their values are. So I've picked the dot here in the first graph, so that is the mean, and it's about 60.1. I'll try and get better into the center of things. That one's 55.9, well, 56. That one's 56. That one is 56.5. So these are the before treatment groups. For penetrating treatment, skin touch, no touch control. And I've got the same for the 24 hours after treatment groups. Now I can ignore all the x-axis values because they're unimportant. The ones that matter are these ones, the y-axis. So now I've got the data for my means, which is good. So what I can do is create an Excel file and put all of those mean values in. So the mean value of the VAS before, I've got 6.06 here. I've got the post value as 3.82. So there's a slight difference depending on whether you use the tool online or the one that you actually purchase. So the one that you purchase gives you a bit more flexibility in terms of making sure that the pixels and the axes are completely horizontal. So I can put in all of those mean values into my chart. The other thing that I need to do is measure the top and the bottom. Those two numbers are for the interquartile ranges. So I've got the third quartile and I've got the first quartile for pre, and they are 74.8 in this case and 47.1, so 4.71 and 7.48. So there's difference in the third decimal place. So I can work out the interquartile range. Then the standard deviation will be the interquartile range divided by 1.35. So here, difference between the two divided by 1.35. and I repeat the process for all of the different groups, giving me these standard deviations. Now these are significantly larger than the standard deviations from all of the other experiments. Looking at the data, these are particularly wide. So if you look at these boxes in the box plot, they almost cover the complete range of the VAS scale from 0 all the way up to, well, the top of the outer bar is over 70. So they cover 70% of the complete range that you're going to do. These are unusually wide. It can be reflected that this is a larger sample size. So when you do the standard errors, this will reduce because you've got a bigger sample size than you've got in the other studies. But still, this is slightly unusual.